So, have you ever just stopped and wondered how our completely chaotic digital world actually works? I mean, we've got billions of devices all trying to talk at the same time over the very same internet. How does it not just collapse into a giant, messy traffic jam? Well, the answer is pretty amazing, and it all comes down to solving a problem that starts right inside our own homes.
Just think about your own house right now. You might be on a work call, your kid is streaming a 4K movie, someone else is in a massive online game. All of that data is flying through one single Wi-Fi connection. It feels like it should just break, right? Well, that's the fundamental mystery we're going to unravel today. In the world of computer networking, this puzzle actually has a name. It's called the multiple access problem. And really, it's the core challenge of figuring out how to let everybody share a single resource, like a cable or a radio wave, without it turning into total chaos. It's all about creating rules so everyone can play nice in the same sandbox.
And honestly, the best way to think about this is to imagine you're at a crowded cocktail party. How do you actually have a conversation? You can't have everyone yelling at once, right? It would just be noise. So we have these unspoken social rules. You wait for a pause, you try not to interrupt people. The internet basically had to invent its own set of cocktail party etiquette for computers.
So, way back when, the engineers who built the internet had a huge choice to make. They could have gone with something called circuit switching. Think of the old phone system, where you get your own private, dedicated line for a call. But that's incredibly wasteful. Most of what we do online is bursty. We send a quick message, then we wait. So instead, they chose the brilliant solution, packet switching, where we all just agree to share one big public highway. And this is how it works. Your email, that movie you're streaming, your video game data, it doesn't travel in one giant piece. Nope. It gets chopped up into thousands of tiny little pieces called packets. You can think of them like a whole caravan of cars. Each car gets sent out onto the internet highway and finds its own way, passing through routers, which are like toll booths that tell them where to go next. So the whole process is, honestly, it's kind of beautiful. Your data gets broken up into packets. Each one gets launched into the network on its own. They hop from router to router, maybe all over the world. And then at the other end, they all get put back together in the right order like a perfectly assembled jigsaw puzzle. And all of this happens in the blink of an eye. We're talking milliseconds. It's incredible.
Okay, but for this whole sharing the road thing to work, you absolutely need some rules. I mean, what happens when two cars or packets try to get on the same piece of highway at the exact same time? So let's start by looking at the rules for the wired world, like that classic Ethernet cable you plug into your computer.
The protocol for that has this, well, it's a mouthful of a name, Carrier Sense Multiple Access with Collision Detection. Phew! Or, CSMA/CD for short. But don't let the name scare you. The idea behind it is actually super simple and, well, kind of polite. Let me break it down. It really just boils down to this. Listen, before you talk, seriously, your computer's network card literally listens to the wire. Is it quiet? Is anyone else talking? If it's clear, awesome. It sends its data. This one simple rule prevents the vast majority of problems right off the bat. But, what happens if two devices listen, they both hear silence, and they start talking at the exact same microsecond? Bam, you get a collision. It's the digital version of two people starting to talk at the same time. And this is where the collision detection part kicks in. Both devices immediately stop, wait a random, and the random part is super important, a random amount of time, and then they go back to listening. It's basically the digital way of saying, oh, whoops, sorry, you go ahead. Okay, so that works great for a cable, right? It's like a nice, quiet room where everyone can hear everyone else. But what about the wild world of Wi-Fi? Suddenly, the cocktail party isn't a quiet room anymore. It's a huge, noisy space, maybe with walls and other obstacles in the way. The old rules just aren't going to cut it. This is where we run into a really tricky issue that engineers call the hidden terminal problem. Imagine this. Your laptop can hear the Wi-Fi router, and your phone can hear the router, but your laptop and your phone can't hear each other because maybe you're in different rooms. So your laptop listens, it hears silence, and it starts talking. But at the same time, your phone listens, it also hears silence, and it starts talking too. The result? A big old data collision right at the router that neither of them saw coming. So to fix this, wireless networks use a slightly different approach. It's called Carrier Sense Multiple Access with Collision Avoidance. See that last word, avoidance? That's the whole game changer.
Instead of just detecting collisions and recovering, the goal now is to avoid them from ever happening in the first place.
And how do they do that? Well, basically, by asking for permission to speak. It's kind of like raising your hand in class. Before a device sends a big chunk of data, it can send out a tiny little request to send signal. The router then broadcasts a clear to send signal, which is like the teacher saying, "Okay, everyone, be quiet for a second, it's Sarah's turn to talk."
So when you look at them side by side, you see they're really just two totally different philosophies. The wired world is optimistic. It's like, I'll just talk, and if I happen to interrupt someone, I'll apologize and we'll sort it out. But the wireless world, it has to be more pessimistic, more cautious. It's all about, I'm going to raise my hand and wait to be called on. And what's cool is that each strategy is perfectly suited for its own unique environment.
So when you put all these pieces together, this whole system of organized chaos, you realize that the smooth internet experience we all take for granted, it's not magic. Not at all.
All right, so let's just quickly run through the key takeaways. We started with the big challenge, the multiple access problem. We saw how the internet solved it with packet switching, everyone sharing the road. And we learned that on that road, wired networks use CSMA/CD to detect collisions, while wireless networks have to be more careful and use CSMA/CA to avoid them altogether.
And that is really the big idea here. The reason your digital life feels so seamless, the reason you can game and stream and work all at once, it's not an accident. It's this beautiful, invisible dance of rules and protocols, all acting like super polite, super fast traffic cops, built right into our devices, making millions of decisions every single second.
Now, before we finish, I want you to think about a number for a second. 25 billion.
That was the estimated number of devices hooked up to the internet way back in 2020. I mean, think about that. And since then, that number has just exploded. We have cars, refrigerators, you name it, all coming online. So as we rocket towards a future with maybe trillions of connected devices, you have to ask, how long can our current cocktail party etiquette last? And what brilliant new rules of the road will we need to invent next?